recording. Okay, and Antonio is going to join now.
Awesome.
Welcome, Antonio. How are you today?
Oh, what happened here? Welcome, Antonio.
Give us a shout out if you can hear us and let us know how you're feeling.
Oh, you got a hand.
I've got a wave. Smile and wave, boys. Smile and wave.
Sometimes I still feel a bit like, I'm not quite sure. Does that mean happy or sad? I guess more happy, like, wave, or is that just like, I'm here?
But we'll need to ask him ourselves.
Yeah.
Antonio, what does that mean? Oh, you're good. That's great to hear. We're also very good, thank you. We were just talking about the weather and yeah, about naps. Do you ever take a nap after school? Do you like napping?
What am I trying to draw here?
I know during high school, I never wanted to nap at all. There was no time to nap.
Really?
Yeah. I was always out and about. Hey, Tato.
Wait. Come.
How are you today?
Oh, no, this is not getting good. I give up today. Welcome. Who else is here? Welcome, Tato.
That Table Mountain.
Oh, you got it so fast. I had to downgrade it to like, because my drawing skills weren't so good. But
was the previous one Egypt?
No, I was trying to draw the Eiffel Tower, but
oh wow,
it wasn't working out. Okay, so that's my monument for the day, Table Mountain. Hi, Valerie. I like this idea of drawing things, interesting things in the world. It's like it's a good way for me to practice, and it's like a nice thing to spend time doing at the beginning. Okay. All right, everyone. So while we wait for everyone to join, you know the drill with the maths part of things. So today is going to focus on trig, and I would like you to give these 3 questions a go. Let me just get the different colors. So we'll go make this A, B, C, D, A, B, C, D. So yeah, the focus is on trig. And so it's really important I get a sense of your basic skill set with trig. And so please do that while we wait for our other classmates to join us. And maybe tell us about your exam schedule. I think we were asking about that the other day, but how many of you, when do you write paper 1, when do you write paper 2? Or if you have a choice today, what do you still want to focus on? Elzon, what can you still remember of trigonometry? I know students often, they like, when they say trigonometry, they're like, triangles? That's what I remember.
Wow. That's true. Trigonometry, we did like, is it sin and tan? Like,
Yes.
it was like TAN, and I
Sine,
had
cos,
like,
tan.
yes. I just did it in Afrikaans. It's so crazy how Afrikaans and English like,
They switch it around.
yes, yeah.
What would sine be in Afrikaans? I mean, sorry, I mean my dad's Afrikaans, but I'm not great. What's sine in Afrikaans?
Sign was sin,
Sin.
SIN.
And cos?
Cos was cos, COZ.
Z.
I think
Okay. Interesting.
sin, oh no, sin, cos, and tan. So it's
Okay.
CIN and then COS and then TAN,
Okay.
if I can remember that correctly.
Okay. No, it's always interesting to hear the pronunciations.
Yes, true.
Who's Afrikaans? Is anybody who's Afrikaans first language in the group? Or who's is Xhosa first language, Zulu? I'm always interested to know. I'm trying to learn isiXhosa at the moment because the school where I'm helping at in the day. So I learned my words of the week, mamela, which means listen, and then bantwana, which is children, and then what was the other one? Inkosi, which means thank you. Inkosi, whereas Inkosi is king. It's a bit confusing, but those were my words for the week. So
Wow, that's very cool. And who teaches you this?
my students, because I hear them saying mamela, mamela, which means listen. Okay. Anybody's first language not English here? I'm just interested. Just general curiousness on my part, and then we're going to get going. Okay, Elzon, I think we're about ready to roll. So anything more from you?
Awesome. Nothing from my side, Peter.
Okay, let's get going. Okay, so with these questions, question one is I mean, I suppose I should have specified you can't use a calculator. If you use a calculator, you can just literally type in what the cos of 240 is, and you'd get minus 0.5, which would be B. However, if the question said, oh, Antonio is Afrikaans first language, fantastic. So if you look at using the reduction formula, if we say in this question, you can't use your calculator, then we would use the cos diagram. And we would say, where is 240? So that's 180. And then if I go 60 past that, I get to 240. And in this quadrant, so if you think of the quadrants, we use this thing called the cos diagram. In quadrant 3, cos is negative. Oh, my phone is, let me just turn that off, sorry. Oh, how embarrassing. My apologies. Oh. There's probably someone trying to sell me airtime. Sorry, guys. Okay, so what we have is we have a negative here. And so my phone is really being uncooperative. Okay, so that's negative. And then we had negative a half. Sorry, all right. So it doesn't bug me. Okay, then for the second question, which is this one over here, what rule are you going to use? So when we look at a question like this, you have to find the missing angle theta, which is down here. And there's some rules that you need to know about. I want to know, what rule did you use to solve it? I want you to put that in the chat. Because I want to see if you know the names of the rules. English, Afrikaans, isiXhosa, I don't mind. But what rule did you use, or what rule would you use to try and do question number 2? I'll give you a moment to think about it, because it's important, because a lot of today's questions are going to come from this idea of solving triangles. You can jump on the audio if you like, Valerie, Antonio. Am I going to use the area rule? Am I going to use the sine rule? Am I going to use the cos rule? What do you think? Or if you're feeling very confused and you'd love an explanation, give me a thumbs down. So that I know like you guys are just waiting for me to be like, give you a bit more detail. So we're going to basically, are we hearing anything? Can everybody hear me? Give me a thumbs down if you want more detailed explanation. Ozan, can you hear me okay? Oh, there we go. Okay, Valerie's, yeah.
I can hear you perfectly, Peter.
Okay. All right. So in question 2, this is good because at least I know kind of where we're standing on this. You have to find the missing angle, which is down here, theta. Now you're given, if you ignore the A, B, C, D parts, is what have you actually got? You've got two sides. You've got that side over there and that side over there, and you've got an angle over here. Now, when you're given two sides and an angle, and you're trying to find another angle, we often look for angle and side pairs, and we use what's called the sine rule. So let me show you what I mean. The sine rule says, if I take the sine of an angle, so the sine of 80, and I divide it by the length opposite that. So in this case, what's opposite 80? It's 35. The sine of 80 over 35 is going to be equal to the sine of theta over 16. Notice how I paired up the theta, which I'm really interested in. That's the whole thing that I'm interested in. And 16 is opposite that. Now that's called the sine rule, and it's how we solve for the unknown sides in a triangle. Or it's one of the ways we can use. We still haven't found it though, because remember, our main goal is to find what the theta is. So I'm going to take the 16. Now, in order to move it, I need to times both sides by 16, and that cancels out that. And then I'm going to get whatever this is. So let's try my calculator. 16 times the sine 80 divided by 35, and I'm going to get 0.450197 blah, 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 equals the sine of theta. Now, I don't want that long thing here. What I want is I want the angle that when I put it into sine, it gives me that thing. So I go to my calculator and I go shift, it's called inverse sine. So shift sine 0.45. Also, I could use the memory if I wanted to be perfectly accurate of that. And I should get theta is approximately 26.8 degrees. And so that is what's called, and we're going to do lots of this today, the angle, the option would be C. Okay, give me a thumbs up if you feel like that made sense. Give me a thumbs down if you're still like, whoa, man, this is difficult. Okay, I want to get a sense from you how you're feeling. So just give me those hand signals. So I'll just wait while we wait. Okay, so I see the chats coming through there. Don't see any hand signals yet. Ozan, if you do see something, let me know, but I'm not seeing too much yet. Then the last question for the warm-ups is solve the equation for the domain 0 to 360, and let's solve it for this thing over here. Now, this is what we call a trig equation, because it's got a trig ratio in it. Okay, so how do we handle these? Well, let me write it out first, and I'll show you the method that I use. So like all equations, we always want to isolate the variable. And so I'm going to divide both sides by 4 here. So I divide both sides by 4. And the reason I've done that is it gets rid of this thing. So now I've got the cos of theta equals minus a half. Okay, so now we need to enter into specialized trig land. And I'm going to teach you the general method I use, even though in this case, it's only asking for a specific solution in 0 to 360. I'm going to use it as a teachable moment to show you the general method, and then we can get specific answers from it. So whenever I do a trig equation, I find what's called a reference angle. Give me a thumbs up if you've heard of this thing called a reference angle before. Give me a thumbs down if you've never heard of this reference angle thing. Okay, I'm not saying anything too much yet because I just want to know how much detail to go into. Okay, so some people have heard of it. That's good. So what we have is when we find the reference angle, we don't worry about where this is positive, negative to start with. We just say, what value of theta, when you apply cos to us, gives a half. So it's almost like we're ignoring this negative for the moment. Now, if we do that, we go shift cos of a half, and you're going to get the reference angle of 60 degrees. Now, that reference angle may not be in the right quadrant yet, because that's got to do with the negatives and the positives, but at least we have our basic reference angle. Now we're going to ask ourselves the following question. In what quadrants is cos negative? Now, if we come back to the cos diagram, the cos diagram tells us where things are positive. So everything is positive in the A quadrant, and cos is positive in that quadrant, which means for my answer, we can't be in those two quadrants. We have to be in the quadrants where cos is negative, because when we started our question, cos was a negative a half. So we must be over here and over here. Now, angles of this form, if you're an angle in this quadrant over here, and this is part of the reduction formula, angles in this quadrant are of the form 180 minus theta. And in this quadrant, I realize I'm getting a little bit cluttered, so let me get rid of some of this clutter, which I'm sure is distracting you. Let's do some house cleaning. If we think about those two quadrants, 180 plus theta, theta is the reference angle, which means that for this question, the answer is going to be 180 minus 60, which is 120. And it's also going to be 180 plus theta, which is 240. And so in fact, both this answer over here, 120 and 240 are going to be answers. Now, this method that I've just done is really important because it's the way you solve all trig equations. So I do have a reference angle first, ignore the negative, and then use the quadrants to know where it ends up. And you're going to see it again later today. So if you're feeling confused, don't worry. More help is coming your way. Okay, so we're going to move on from the warm-up there, and hopefully that's given you a bit of a preview of today's lesson. So just to emphasize what we're going to focus on, we're focusing on paper 2, and I've spoken about this in previous lessons. And because of the weight of trigonometry in paper 2, I'm going to spend the whole of today's lesson on trigonometry. Okay, so that's 60 marks. It's a pretty big chunk. And we're going to focus our attention on the sections dealing with knowledge questions, and routine procedures. These ones, we give them a go at the end, but we want to make sure that we bank our marks for these sections. So I'm going to point that out as we go. And I may leave out some of these questions today because of time so that I can focus on these ones over here, which is a good strategy. Okay, so what are some of the things we're going to talk about? So we're going to talk about what's called the reduction formula, which I've hinted at now. I'm just going to do a little bit of recap of theory because I can see you guys are a little bit rusty. So the reduction formula uses what's called the cast diagram. And the cast diagram tells us whether trig ratios are positive or negative. So if I took an angle like, let's say 120, starting here and going to here, 120 would end up here. Now, what this diagram is saying is that if I type in my calculator the sine of 120, it will give me a positive value. But if I type in my calculator the cos of 120, it will give me a negative value, because the S tells us the only ratios that are positive in this quadrant. So just for interest's sake, let's do this. The sine of 120 is equal to 0.86 and so on. And the cos of 120 is equal to minus, wait, I should have put a 120 there. The cos of 120 is equal to minus 0.5. So the story that I'm telling you is, is definitely clear there. Now, when you use the reduction formula, we often reduce angles that are big to angles that are smaller using the horizontal or the vertical. So let me go back to this idea of sine of 120. If I wanted to reduce that to a smaller angle, I would say, first of all, is it positive or negative? It's positive because of the quadrant it's in. And then I'd say, how far away is it from the nearest horizontal? Well, the nearest horizontal is this thing over here, 180 degrees. And it's 60 degrees away. And so if we reduce it, the sine of 120 is actually the same as the sine of 60. And this is an acute angle. It's smaller than the obtuse one. Hence, we say we've reduced it. If we were dealing first with the cos of 120, a very similar idea, except that when we start, it's not going to be positive, it's going to be negative. And then what we do is we would say this is going to be minus the cos of 60. Notice how we're still using the horizontal axis to reduce the angle. It's just that we end up with a negative. And then the other thing we can do is we can use the vertical axis or the co-ratio. Now that is more difficult, but not impossible. And I just want to give me a thumbs up if you've heard of reducing off the vertical. Give me a thumbs down if you've never heard of reducing a trig ratio off the vertical. So thumbs up if you've heard of using the vertical axis. Thumbs down if you've never heard of it. Okay, thumbs down. So I would only use the vertical when you have to. Sometimes, most of the time, I would use the horizontal because it's easier to remember because the trig ratios stay the same. It's sine with sine and cos with cos. But sometimes you're forced to use the vertical. So the vertical axis is going to be at 90 and also at 270. And if you were going the other way around, it would be minus 90 and minus 270. So, Valerie, what do you think? How far away is 120 degrees from the nearest vertical axis? I'm going to draw this back in. How far away is 120 from the nearest vertical axis? Get rid of this in the meantime. Get rid of these two. So focus on that. How far away is it? Is there any answers there in the chats? I've lost my chat stream for a second. Who would like to jump in? How far away is this red thing from this line over here? What I'll call the vertical. So I'm here. Remember, this whole angle is 120. Any ideas? I'll give you guys a moment to think about that. So the question might be, I want to reduce the sine of 120, and I'm going to use the vertical axis. And I need to know how far away is 120 from the nearest vertical axis. And I'd love to hear someone's voice. Make me a happy teacher and pop on the mic. Or put it in the chat. Either way, what do you guys have for me? And again, there's no prizes for getting it right. It's for showing the enthusiasm to pitch up that I really want to cheer you on for. What do you think, Valerie? Antonio? Who else is in the room? I can't see that. Is that? I can't see the name on. Any ideas?
Also.
Who is it?
Tato.
Tato. Tato, what do you think? What's the distance to the nearest vertical here? So I want to suggest that it's 30 degrees, because if it's 120, so 90 plus 30 gives you 120. So the nearest vertical is 30 degrees. And when we use basically, we start with the positive and negative things. So sine of 120 is still going to be positive, but when we change it, when we reduce it off the vertical, we have to change it to its co-ratio. So we say it's the cos of 30. So that's a little bit weird, but you can try this in your calculators. Type in the sine of 120 and we get a value. And if you type in the cos of 30, we get the same value. Okay, so you might see that come up later in the lesson with all exams, and it's an important skill, but most of the time we'll spend using the horizontal. And then, okay, I tell you what, that's a little bit of theory about the reduction formula. The rest we can do in the questions. So let's do another one like this. Let's do some more multiple choice questions. So I want you guys, and this is over to you guys, I want you to try and find this unknown side here called X, and then vote in the chat. And I'm going to give you a hint. You don't have to use the sine rule. There's another rule in trigonometry that we can use. Does anybody know what it's called? Anybody know what the rule we will use for this is called? I want to give you that hint and make sure you've got the tools for the job. What are the three rules? There's three rules that we need to use in trigonometry to solve. The one is the sine rule, or the sin rule if you're Afrikaans. What are the other two rules that you need to know about? Indeed. The cos rule, yes. I'm afraid there's no tan rule, Alzan. There is no tan rule, but there is what's called the area rule. So there's three rules. Actually, I lied. There is a tan rule, but we don't cover it in the syllabus. Okay, so you're not completely wrong. But the cos rule is basically can be written in a number of forms, but probably the easiest way to think of it is a little bit like Pythagoras on steroids. So what you say using the cos rule is one side of the triangle, if you square it, is equal to the other side squared plus the other side squared minus 2 times those two sides that you were talking about earlier, times the cos of the angle opposite your original side. And you can rearrange this. You can rearrange this if you need to, but the first part looks a lot like Pythagoras, and then there's just this extra bit like that. So that is what's called the cos rule. Now, can you apply that to this one over here? But in this case, I want you to start with x squared, because x is what you're after. So I want you to sub in the values and see, can you get me a value for x, which is your answer, and then vote. Oh, Valerie, I see your vote. You are quite right. We're using the cosine rule. Okay, so now, guys, I want you to sub in. I want you to sub in the values from the question and see if you can get to the final answer. And then when you get it, I want you to vote by saying 10A, 10B, 10C, 10D. I'm not going to speed up because I think clearly this area needs attention. I'd rather slow down and do it properly. Okay, so if I'm going too fast for you, I'm going to slow down. And I want you to give it a proper go. So you've got the x squared, which is this side. What are the two other sides left in the triangle? We've got the 6. So we'd go 6 squared. What else has to go in there? And then see if you can give me your answer. And remember, I'm not after x squared. I'm after x. So to get some water. What do you think, Antonio? What do you think the answer is? So what have we got left? We've got the 7 squared. So that's the 6 squared plus the 7 squared minus 2 times 6 times 7. Now, what's the cos of what angle? Ooh, it's the cos of the angle opposite the original side. So it's the cos of 19. Now what we have to do is we have to find a way to get x by itself. Well, this is like sitting in a different layer somehow. Okay, well, you've got a calculator, and then how do you undo the squared part? That's what I want to know. Okay, so we're still waiting for our answers. And then I'd like to see you vote in the chat. Plus 7 squared minus 2 times 6 times 7 times the cos of 19. And then I get 5.57, but now I want it to be square rooted. So I'm going to say square root answer. And I've got my answer. What is yours? I don't want to give the cat out the bag here. Or even if you take a guess, I just want to make sure that you are with me. That you're not a Russian bot pretending to be there. So I want to see a vote, A, B, C, or D. And then I will reveal the answer. Okay. So the answer should be, in the end, it should be A. Okay. Give me a thumbs up if that made sense to you. Give me a thumbs down if it didn't make sense. Okay. Do you want to do another one like this, Valerie, Antonio? Because I feel like you guys still need a bit more practice. Would you like to do another one? Give me another thumbs up if you want to do another one like this to practice. Give me a thumbs down if you want to move on. Okay, let's do another one then to practice. So let's bring this one out. Okay, so if you look at this question at the moment, it says find BC. Let me get rid of this stuff here. Obviously, I have layers upon layers upon layers. And let's make off, this is hard enough by itself. So let me make sure that everything is out the way and that you guys can just focus on this question. Sorry for my moving around. Okay, so you have to find BC. The question actually asks you for what law should you use, and I want you to think about what law to use. But what I really want is I want you to find the value of BC for me, and then I want you to put that in the chat. And I'm not going to give you any extra help here. I want you to use what we did in the previous question. Okay, it's not the law of the jungle, I promise. And it's not the law of gravity. So Those two are gone. Okay, so Valerie, I see that law of sines. I think you're onto something because look, you've got a matching pair. The 79 is opposite the 18, and the side you want is opposite the 68. Now I'll teach you another little trick. The law of sines can be written with the sides on top or the angles on top, as long as you're consistent. So really, if you want BC, why not put that at the top? Because that will save you the most trouble. But then later on, when you write the other side that's involved, which will be 18, that also has to be at the top. Now, the question is what goes at the bottom then? And that's what I want you to think about. And then hopefully that will help you. So opposite BC is 68, which since it's the law of sines, it's going to be sine 68. What's going to be over here? Well, it's going to be the sine of 79. So you have to find a way to get this thing by itself. And then I want you to put that in the chat for me. And what do you get? Antonio, what do you get for BC? So if you think about it, the only thing that's stopping us is the sine 68. So why don't we multiply both sides by the sine of 68? Let me get a pen here. So if I multiply this side by the sine of 68 and this side by the sine of 68, I get that. And so in my calculator, I'm just going to type the sine of 68, close the bracket, times 18 divided by the sine of 79, and I get, what's the answer? So it should be 17, and it doesn't give units, but I'll say centimeters, which kind of makes sense. If you look at the angle difference, it's going to be in that region. Oh, well done, Valerie. Well done. Yes. You're getting this. Well done. Okay, well, I'll tell you what, let's go to an old exam question because I feel like we've warmed up enough in terms of doing something. Now, that's the trig there. Okay, let me explain. This is straight out of a old exam paper, and I want to kind of explain what's going on and which of these questions are knowledge, which of these questions are routine procedures, etc. Now, when students encounter the exam question, there's a lot of language and detail, and they get a bit overwhelmed. Now, this whole thing is out of 12 marks, but some of these marks are much easier than others. And I just want to point this out to you. This first question, show that this is equal to that, is relating to this question over here, but this is bordering on a complex procedure. What you want to do, the really easy marks are when you actually substitute in. So if you feel confused by this first question, that's okay, but don't move on to the next question until you have completed these marks over here. And what this question says, it says, look, if X is 2.4 units, so it's literally telling you X is 2.4, calculate theta. Then it's given you this relationship that you had to show in the previous question, but you can use it. So what they're doing is they're making these next two questions much more easy. So all you have to do in this question is say, okay, well, the cos of theta is equal to something squared plus 3 over 4 times that something. Now, they have told you, they've stated, they said, if this is true, if this is X is 2.4, which means this thing over here must be 2.4, which means you've now got a trig equation to find what cos is. So can you, Valerie, find for me, and Antonia, find for me what is the value of theta in this question? And then I'll go on to the next one. But I want you to just, first of all, make sure you can find the value of theta. And notice how it's 3 marks for sure in the bag. So I'll give you a bit of time. What's the answer for that? So we're going to have to get some sort of number for this thing. So 2.4 squared, okay, plus 3 equals 8.76 divided by 4 times 2.4, and I get 0.9125. So what is the angle theta I get? So I go, oh, I see the answers coming there, Valerie. I'll give you confirmation now in a moment. So shift cos 0.9125, and we do indeed get 24.14. Well done. Okay. So that's 3 marks in the bag, 25% already. Now, what we need to do is we have to calculate the area of triangle PQR. Now, PQR is this triangle up here. Now, remember earlier on, I said to you, there's something called the area rule. So what the area rule says is it basically says, if I've got a triangle, I can take half times one side times another side times the sine of the angle in between those two sides. And it's often said like this, like half AB sine C or a half BC sine A. Now that looks a bit scary, so I'll show you on the drawing. If you think about this as being a half times that length times this length over here times the sine of the angle in between those two, that would be how you would use the area rule. But you have to think, which two sides should I use and what information have I already worked out in the question? So I want to give you a bit of time to try and work that out with that hint. So you need to find me the area of this triangle, okay? And I'm going to say to you, look, you know what X is because in the question, they've told you it's 2.4. You've just worked out what theta is. Now, can you put that together so that you can work out the area of this triangle? I'll give you some time for that. Welcome, Sinosipo. I see you have joined us. We are doing trig questions from paper 2 at the moment. So I don't know what this angle is over here, which means that even if I know the two sides, I can't really use the sine rule. But the one angle that I do know, which I've just worked out, is this one up here, which is 24.14 degrees. So if I wanted to use the area rule, I could use that side, I could use that side, and I could use the angle in between. So could I work out what 2x is? Well, I know what x is, so see if you can use that to help you get to the area. And then pop it in the chat once you've worked it out. So 2 times 2.4, I think that would be 4.8. I know that's 3. So what does the area calculation look like? A half times something times the sine of a particular angle. Okay, I see some answers coming through. Let me just change my color. So I'm going to get, what did we say? So it's a half times 4.8 times 3 times the sine of 24.14. So we go 0.5 times 4.8 times 3 times the sine of 24.14, close brackets, and we get, oh, I see, have you given us an answer there, Valerie? So I get 2.94, and that would be the area in units squared. So half that times the sine of angle in between, yeah. So that would be, I get 2.94. Let me just check that. 0.5 times 4.8 times 3 times the sine of 24.14. There might be some minor rounding differences, but yeah. And this would be units squared or centimeters squared. Okay, so we've done these two over here. I don't know, are there any questions, guys? Any comments, any questions? Then how do we actually do this original question? Let's go back for a moment. We've got the 5 marks out of the 12. And so now we're going to try and do a slightly harder question, but it's actually not that hard. We just have to show that this relationship is true. So let's think about what we've got. When we started this question, what rule has a cos in it? If we think about it, there's a sine rule, a cos rule, and an area rule. And only one of them has a cos in it. So if I want to show something, I surely have to use the rule that has a cos in it. So let's see if we can show this relationship, because it says show using the cos rule. So I know that I need a cos of theta. So if I think about how we did it earlier, let's go x squared. So I'm taking this, remember, it's like Pythagoras on steroids. X squared equals 2x squared plus 3 squared. Now, if I stop there, that would be Pythagoras, but that wouldn't be very helpful because this is not a right angled triangle. So now I go minus 2 times by, let me just move this out the way, minus 2 times by something times the cos of some angle. So that angle is going to be theta because it's opposite the original. And these two things are going to be 2x and 3. Now that is, this is a little bit harder. I would call this a complex procedure, but at least we're on the right track here. Now 2x squared is actually 4x squared. 3 squared is 9. And then minus 2 times 2x is minus 4x. Times 3 is minus 12x cos theta. Okay, so we're getting warmer here. Now we need to get this cos theta all by itself. So I'm going to move these things around. So if I do that, I'm going to take away 4x squareds from both sides. So I'm going to get x squared minus 4x squared, and then minus 9 equals minus 12x cos theta. And then what does this give us? Well, that's going to give us minus 3x squared minus 9 equals minus 12x cos theta. And then I'm going to divide both sides by 12x. Let's have a look. Have I made a silly mistake here? No, I don't think x minus 3, x plus 3. No, I'll get there now. So if I divide minus 3, okay, this is a little bit sneaky, x plus 3, and then this, sorry guys, this is turning into a bit of a mouthful here. So then what we're going to have is minus, so basically this over that is 4, and so we get x plus 3 over 4x is cos theta. Ooh. Oh, x squared. Sorry, I left the x squared out. X squared plus 3 over 4x. Okay, so can you see that that one was, it's not impossible, but it's a little bit harder. And so that's why I was recommending to say, look, even if that really confused you, there was lots of simple marks that were sitting over here. And then this last one over here, I would call this a problem solving or complex procedure one as well. Okay, so I just wanted to model that strategy for you so that you see that even though there were some tough questions here, you could get 5 out of 12. You should definitely be aiming to get at least those 5 out of 12 correct. Give me a thumbs up if that sort of strategy was helpful. Give me a thumbs down if that wasn't that helpful. I'm just wondering if I should keep kind of showing you those techniques. Okay, let's wait. Okay, last question of the day. So another exam question, and that was actually quite a tough old exam question. This is 6 marks, and we're going to finish with this today. So you're given a quadrilateral, something with 4 sides. You're given all this, and you need to find BD. So you need to find BD, which is this, and you need to find CD, which is this over here. So you need to find those 2 sides, and I want you to use either the sine rule or the cos rule to help you do that. And then we'll call it a day for today. Okay. There we go. Okay. First question is hard, but others are good. I'm glad it's helping, Valerie. Valerie, what do you think? What rule should we use for this one? For solving for the sides of a triangle? So we've got that angle and that angle, and we've got this side. And we're trying to find this side. What rule do you think we're going to use? I feel like this reminds me of earlier on where we were looking for the pairs of sides and angles. So I'm going to suggest that we write down BD first and go from there. Yes, it's going to be sine. Well done, Valerie. Well done. So now what goes with BD? It's going to be the sine of 109.16. And then what is the other pair? Now we need to make sure we use the side on top first. So we need to use the side 90.52 over here. And then we need to use the sine of 31.23 over here. And so now you need to get this by itself to give me my answer. So I'll wait and see, and we can compare. Sinosipo, also Antonio, let's see if you guys can put an answer in the chat and we can compare. And again, it's just doing the activity, even if you get it wrong for now, is definitely going to help. So we have to think about how do we deal with this sign of 109.16 that's hanging out at the bottom here. What can we do using the laws of equations? So I'm going to use my calculator in the meantime. So 90.52, 3, and then 101.16. Okay, I have my answer, but let's compare it to you guys. What do you think I'm going to get for BD? So I get 164.92 if I'm rounding off. And now I need to, the final question is to find out what this thing is over here. And so we have to ask ourselves, should I use the sine rule or should I use the cos rule in this case? Now, what's interesting about this case is it looks to me, and this always gives a bit of a, we've got one side already over here, we've got one side over here, and we've got the angle in between. And when we see that shape, when we've got two sides and the angle in between, and we're trying to find the third side, it always means we're not going to use the sine rule, we're going to use the cos rule. It gets used when you have two sides and the included angle. And so it's going to be that Pythagoras on steroids thing that I keep talking about. So you were going to start by writing CD squared equals, and I want you to try and write out what comes next. And then we'll end with that question. I'll give you some of the structure here. I'm going to close my... So, what do we got sides here? We've got the 235, but it's not just 235. I was being sneaky. It has to be squared. And then we've got 164.92 squared. And then over here, that's 235, 164.92. And then the cos of the angle is 48.88. Now, we obviously are going to have to get some sort of number for all this. So 235 squared plus 164.92 squared minus 2 times 235 times 164.92 times the cos of 48.88. And the number I get is 31,448.487939. And then I'm just going to use my calculator. Oh, look at that. I'm going to go square root answer. And I get 177.34 in terms of length. And that broadly is in line with what I expect. 177.34. If you look at that's 164, that's 235. All right, guys, what we're almost ready to hand back to Alzan. I just want to say this is the last of basically one of the sessions on exam prep, but I am going to take questions as you need in the next lesson. Or if nobody has questions, I'm going to do what's called Euclidean geometry or circle geometry. But if you would like me to do a different topic, I'm happy to adapt. And I do hope that that was helpful. So I'm going to hand back to you, Alzan. And yeah, thanks.
Thank you, Peter, for all the hard work today. I would just love to know from the learners, how are you guys feeling? Please feel free to unmute yourself. Give us some feedback on how this lesson was for you. Was it difficult? Were you guys just silent because you're shy, or were you silent because you were concentrating so hard? Let us know.
Totally, yeah. There we go. Yeah, this topic can be a little bit tough sometimes, especially if the basics haven't been consolidated. That's why I kind of think it's good to kind of strategically do the questions that you know that you have some grounding in, and then go from that point forward.
So maybe out of 5, if we can do a rating, like where are you at with this specific topic? 1 being you still have a lot of work to do to get to 5, and 5 being you feel confident in this topic. So rate where you are at. Awesome. Valerie, we've got a 4 from Valerie. You guys can be honest, hey?
Yeah.
Kinesipu, Antonio, where are you guys at? Let's hear from you guys.
I wonder if they've had some serious load shedding or Tom is struck back. And yeah.
Okay, well, let me know on the chat on the Watobe app if you can't hear me now. But yeah, guys, thank you so much for joining in again. If there's any questions that you have, like Peter said, please feel free to ask them for next week. So you can also just put that in the chat on your Watobe app, anything you'd like to know about maths before your exams. Otherwise, we'll see you again on Tuesday. And yeah, is there anything else from you, Peter?
So yeah, just to say, on the next week's sessions are down as Q&A. So I'm really quite happy to do anything that the particular students who are coming want to talk about. Otherwise, I'll just carry on making sure that I'm covering all the topics that maybe haven't been given enough attention so far. But really, it's up to the students we're quite happy to adapt. So yeah, that's it.
Awesome. Okay, well, that's all from our side. Take care, guys. Enjoy the rest of your evening.
Cheers, Alzan. Cheers, everyone. Bye,
Peter.
Antonio.
Take care.
Bye, Sinosipo. Yep. Enjoy the rest of the long evenings while the sun is here. Ciao. All right.